Hello everyone, this is Siddharth from QA Infotech, anchoring today's webinar and supporting the event logistically. On behalf of QA Infotech, I would like to thank and welcome you all to this web event on a practical solution to smart devices application test automation. With technology evolving at a fast pace, our day-to-day lives are witnessing a revolutionary change where mobile applications and smart devices play a significant role. For example, these devices are being increasingly used for tasks such as online secure transactions, including shopping, banking, completing and submitting student assignments on LMSs to name a few. On the engineering side, the growing need for agility is forcing shorter build, test, deploy cycles, whereas the test matrix is ever expanding with newer OS, browsers, and a plethora of smart devices on which applications are supported. Being a quality assurance company, our commitment remains to ensure that the builds going out to production are thoroughly tested on all the supported platforms to ensure product integrity and quality. Now, with frequent new builds, it becomes a humongous task to test applications on all supported devices and platforms. With these inherent delivery constraints, the proverbial dilemma exists around quality versus time. Test automation for desktop web applications is a well-known methodology. The current gripping challenge is around testing and maintaining the integrity for smart or mobile devices. We often receive questions around, is test automation even feasible on smart devices? If so, what is the scope or tools and technologies to leverage? What is a sustainable test process and what are the ground level challenges and solutions to automate on smart devices? The agenda for today's webinar is to discuss these questions and solutions and how we can evolve our test processes to gain a leading edge in the mobile wave. Our speakers for today are Kunal Chauhan, the CTO of QA Infotech, and Ramandeep Singh, who is the head of our test automation group. We will start off with Kunal, who will be providing an overview on test automation on smart devices, followed by Ramandeep, who will be delivering further into the practical implementation of these solutions at QA Infotech. Please feel free to send your questions to us anytime during the event using the Questions tab on the GoToWebinar platform. At the end of this session, we will try to answer as many questions as time permits. All participants are on mute at this time to allow for the speakers to present. Over to Kunal now.
Thanks, Sid, for the introduction, and let me welcome the audience once again to our session today. As Sid mentioned in his welcome note, smart devices penetration has been huge over the last few years. The mobile landscape is growing by the day with unlimited potential, posing tough yet interesting problems for product companies to build applications that are reliable, scalable, and compatible across platforms. We are excited to be showing you all the work we have done in the automated testing for mobile devices applications. Talking about the agenda, I will start off discussing the overall mobile landscape, touching upon the spectrum as it exists today. Raman will then take over to discuss what challenges a QA team is faced with, what commercial and open source tools can be leveraged in the automation process, and talk about the varied application automation types such as native, web, and hybrid. While talking about each of these, he will also showcase a demo on how we have handled these internally in our R&D lab. This, we hope, will make the presentation very meaningful and relevant to you all in solving similar challenges at your end. As we start off, to get us all on the same page at very high level, by smart devices, we refer to devices that enable voice, video communication, have access to the internet, and support varied type of applications to enable end-user computing. Even before one starts thinking about smart devices application test automation, let's look at the overall landscape or possibilities we need to keep in mind to build a comprehensive testing strategy covering both manual and automated techniques. We'll look at this also from both the software and hardware angles. On the software side, we have the underlying platform and supported applications at play. The platform ranges across closed and open source options all the way from iOS, Android, BlackBerry, Windows Mobile, Windows Phone, Symbian, Memo, and MeeGo, to name a few. For form factor, you have the flip or slide, bars, and touchscreens. For input method, user can type and multi-touch, use gestures like pinch to enlarge and reduce the size, slide across screens, scroll up and down, and talk to give the input. As for applications that are supported on these platforms, you have the native built-in applications as part of the vendor's repository, web applications that are extended to work on mobile platforms, as well as hybrid applications. Depending on what kind of application needs to be tested, the strategy needs to be customized. While one needs to understand the available options and the need to optimize them for testing purposes, the goal of our discussion over the remainder of this session will be around the various application types supported on smart devices, automation tools that exist for each of them, and a live demo to see a practical implementation in each of these types. Over to Raman now to discuss these in detail.
Thank you, Kunal. Hello, everyone. Let me take a couple more minutes to talk more about the smart device applications first. Native applications. These are the kind of applications that are built targeting specific smart device platform. For instance, there are Android applications that are built for Android-based phones and tablets. Then there are iOS applications, the applications that are built for iPhone and iTab. Then there are Java-based applications. So these are the applications that are supported on phones that support Java platform. And like Kunal already said, web applications are our everyday applications that we access using our web browsers on our desktops, PCs, Macs, and laptops. And same applications are further enhanced for viewing inside the web browsers of smart devices. These are the applications that are built using HTML, HTML5, JavaScript, CSS. Thirdly, there are hybrid applications. Now, hybrid applications can be called as a combination of both native application and web application, because these kinds of applications provide both the user experiences to the end user, whether it's the experience of using a native application in the native context, being able to use the application workflows ending on the application and the device hardware, to the experience of a web application where the user always gets up-to-date runtime content right in front of him on the screen of the application. There are a number of frameworks available for application developers which can be used to develop hybrid application in a very rapid fashion. Frameworks like PhoneGap and Accelerated Titanium are few in this line. When we want to develop, when an application developer wants to develop a native application, he first needs to pick which platform this application is supposed to support. If he picks Android platform, he would use the Android's native libraries to develop the application on top of it. And such application will not be usable in iOS context, in iPhones and iPads, and the other way around as well. But in case of hybrid applications, because of availability of these application development frameworks like PhoneGap and Accelerated Titanium, it is really easy for the application developers to build the application in a single code line and publish this application into multiple native applications for different smart devices using these frameworks. That is why nowadays hybrid application is the primary choice of developing applications for smart devices. Now, before we talk about test automation, let us quickly look at a small demo. The demo that we are going to see is of an iPhone application. This is a live application, a financial app which is built for one of our clients. And in order to make sure that the client confidentiality is maintained, we have changed the branding of this application for this demo purpose. Let me change my screen so that we can see the demo. This application was built for iPhone. It's a native application, and you can see that the script that is running, it is able to interact with the application. It has launched the application in the iPhone emulator. It is interacting with the different tabs of the application for navigating between them. Now it is filling up a text field, then clicking on some buttons. So the application is able to interact with the application UI. The test automation code is able to interact with the application UI, fill up the forms, do necessary validation by extracting text from the different objects in the fields of the application, and also the script is able to synchronize between the state changes of the application. And in the end, you would see that when I click on the final button, it would throw a pop-up, and the script is able to handle the pop-ups inside the iOS application as well. Let us look at the available options that we have for test automation of smart devices. Commercially, there's a very popular option out there, which is called a C-test. This is a tool that was developed by a company called Xperitest in collaboration with a number of device developers like Motorola and HP. The primary purpose of this tool was to be able to do device testing and smart device OS testing. But this tool, C-test, can also be extended to do testing of smart device applications. MEUX is another tool. It is in fact a plugin that can be installed on any smart device, and then the application of that smart device can be controlled externally through test automation tools like Qtp or Siltest, or primal languages like Java, Python, Ruby, and Perl. This tool provides the opportunity for test automation engineers to develop test automation solutions using either commercial test automation tools like Qtp or build their own test frameworks using primal languages on top of this plugin. As part of QInfotech's test automation group, our focus is to build test automation solutions using open source technologies and techniques that are available out there because of their cost effectiveness. And when we talk about open source tools and technologies, Selenium is by far the most popular tool when it comes to automating web applications in the open source technology arena. Selenium is not only a tool that can automate web applications on desktops, PCs, and Macs, but also on smart devices like iOS and Android. Sequely is another open source tool which is an image-based UI test automation tool, and in combination with a number of different technologies like screencast or VNC for smart devices, Sequely can be used for test automation of native, hybrid, as well as web applications on smart devices. MonkeyTalk is a tool that is developed by a company called Gorilla Logic, and this tool supports test automation of native as well as web applications. Robotium is an open source tool that is available for test automation of native applications on Android platform. Over the course of this presentation, we would look at a number of solutions and demos of those solutions that are built using a bunch of these open source tools. But before we talk about those solutions that we have developed, let us try and understand what are the challenges of test automation of smart device applications. When we talk about test automation, what comes into my mind is that there are two methodologies of doing test automation. One is doing context-driven test automation, where the test automation tool would identify the objects of the application UI through their context, like what is the class name of the object, what is the ID of the object. And once the object is identified, a user action is simulated on that object by the test automation tool. And the user action could be clicking on the object, typing inside the object, dragging the object. And the other methodology is a non-context sensitive, a non-context driven automation, or an analog way of doing automation, in which the object on the screen cannot be identified, but rather a user action is simulated on the screen based on the location on the screen, like the XY coordinates, or by identifying the location of the object through image comparison. Now, we all know that analog test automation is not robust. It is not stable. We require a lot of maintenance over the course of a longer test automation project, because the UI of the application and the resolution and a number of other factors that hinder the performance of this kind of a solution, they keep on changing. So the only robust and stable way of doing test automation is to be able to do context-driven UI test automation. In case of smart devices, there are a number of test automation tools that are available, both open source and commercial, that can do context-driven UI test automation of native applications. But the challenge is that such tools cannot identify the application UI of a hybrid application, because hybrid applications do not have a UI which is rendered from the native smart device OS's libraries. Hybrid applications can be called as web applications that are running in context of a native application. The UI in hybrid applications, whether they are built using tools like PhoneGap or Accelerator Titanium, the UI is built entirely on HTML and JavaScript. And these are essentially third-party libraries which are not native to the smart device OS. Hence, the native application UI automation tool for such smart devices cannot automate hybrid applications in a context-driven mode. This is one of the very important challenges for smart device test automation. Another challenge is that when we were talking about test automation on PCs, Macs, and Windows machines, there are a number of tools available out there using which we can inspect the UI of the application and identify the application objects, the UI objects, in their native context, like the ID, the class name, the XPath of those objects. But for smart devices, such tools for inspecting the UI of the application at runtime are not available. So in order to be able to capture the application's UI information and pass on this information to the automation tool, the only possible way of doing this is if we have the source code of the native or the hybrid application available. Once we have the source code, we can extract this necessary information from the source code and pass it on to the test automation tool, which can then take over and do test automation for us. So that is one of the very important challenges, that for doing robust context-driven test automation, we need source code of the native application available. Now, besides these two important test automation challenges, there are a number of other challenges for test automation, but which are common across test automation arena, whether we are talking about test automation of smart device applications or desktop-based applications or web applications. These challenges are test stability. How effective is my test case? Would it actually return the investment that I've made on it? Would I be able to get a structured reporting that would be able to satisfy all my reporting needs? Can I integrate this, the solution that I built, with my existing build, test, deploy, continuous integration process? But these challenges, the remaining bottom three challenges, are since common across the test automation arena. We are not going to focus on these challenges, but for the next few slides, we will be focusing on only the challenges for smart device test automation. Native application test automation. We have already seen a demo of an iOS application, a native application, which was automated using one of the scripts. This was done using a utility called as UI automation. UI automation is a utility that comes in bundled with iOS SDK. This utility takes advantage of the accessibility feature of iOS, and it can do context-driven UI automation of any iOS native application, provided we have the source code of the application available. Similarly, MonkeyTalk is a tool that can do context-driven UI automation of iOS applications as well as Android applications, provided we have the source code of these native applications available. Now, in case we do not have the source code of the application, situations where the QA team is a third-party vendor to the development team and the development is not willing to share the source code of the application to the test team, in that case, it is really difficult to do context-driven UI automation because the QA team does not have the source code of the application. So in that case, we can fall back to the secondary option of test automation, which is doing analog non-context driven UI automation. In that case, what we can do is we can use a utility called a screencast. Screencast is a mechanism to port the screen, the view, and the input of any smart device to a desktop PC. And once the view and the input of the desktop of the smart device is redirected to a PC, from there we can use any image-based commercial and open source UI automation tool to do automation on top of it. The tool would act on the PC, the simulation would happen on the PC, but because the UI and the input is redirected, the actual action would take place inside the device. And using this approach, we would be able to automate both the device as well as the smart device applications installed on that device. At the end of the slide, I would show you a demo of the similar approach. Now, like iOS UI automation, Robotium, as we have already talked about, is a test automation tool for Android. Now, let us quickly look at the demo. What we have done is we've been able to integrate one of our existing test automation frameworks and extend it with SQL and image-based UI automation. What you see on the screen in front of you is the demo of that. Our framework uses a wiki-based interface for authoring and creating the automated test cases as well as a place to execute the test. Let me quickly run this test. What I would do is I would go to the test first and on what you can see on the right of the device and look at the device. In this device, which is on the screen and I can the device inside the device. You see, I can on the screen for the full execution and that is very highly understandable test report available to us. Web applications. Now, compared to native application, test automation of web application, whether it's on smart devices or whether it's on desktop and PC browser, it is really easy. All because of availability of the tool, Selenium WebDriver. WebDriver not only has capability to automate applications inside browsers running on Windows, desktops, Mac machines, but also on browsers running on smart devices. It has drivers for both Android as well as iOS. Let me quickly show you a demo of Selenium. What we have done in this case is that I've created a Selenium script. First, I'm launching the WebDriver on my device. It's a Samsung Smart device, an Android-based device, and then I've started the script on my desktop. And since the script would remotely connect to the driver that is running inside the smart device, the browser is launched inside the device. Wikipedia is open, and it is now searching. The script is now searching for Hans Zimmer inside Wikipedia on the web browser of an Android device. It would, once the page is open, it would extract some text from there, like the full name of the person, the date of birth of the person. And then the same script would launch. It has just done that. It has launched IMDb application on the web browser. Now it is searching for the same person again, Hans Zimmer. And it would open the page, profile page for this person, and it would compare the values, the full name, the birth name, and the date of birth from the two web applications. So this is the end-to-end workflow, and you can see the detailed report coming right in front of me in form of the number of tests that were executed and failures and past success. You can also see the report in the HTML version. So what I've done here is I've used my existing test automation framework to be able to run a test automation code for smart device application, smart device web application in this case. In case where the web applications have components that cannot be automated through Selenium, for instance, if the application has a Flash component, has a Flash applet, we know that Android devices now support Flash applets as well. So in those cases, the traditional method of integrating our Selenium-based frameworks with tools like AutoIt or Sequely or Screencast plus image-based UI automation can still be done in this case also to solve challenges where Selenium is not able to automate specific areas of the web application by itself. Hybrid applications. Now, by far, compared to both native applications and web applications, the test automation of hybrid applications is the most challenging one. Reason? Because hybrid applications do not have a native rendered UI. These applications use the third-party libraries to render the UI. Essentially, they are HTML and JavaScript-based UI, which is running in a native context. So this is not a web application. So Selenium cannot automate it, and this is not an entirely a native application, and hence the native application test automation tools cannot automate it. So what are our options to automate hybrid applications? Well, we can definitely fall back to analog way of test automation, where we can use screencast plus image-based UI automation. But as part of our research for developing test automation solutions for smart devices, we have been able to develop a small JavaScript library, a JavaScript micro framework that, when integrated with the code of smart device application, a hybrid application, and when this application is installed on a smart device, this micro framework can be used to control the test flow of this application by feeding external scripts to it. Let me quickly show you a demo of this as well. What you see up on the screen is an emulator of Android tablet. The application that we have automated is built using PhoneGap. So it's a hybrid application. This application is actually an evaluation app, which is a very core part of a web-based learning management system, an LMS. So this is one of the very important part. Since this application was developed in multiple cycles, so regression testing was a very important part of the overall test strategy of this application. So with this automation in place, we were able to turn around the regression testing in very quick time. So when I play this automation, you will see that the code is, the script is able to launch the application. It is able to interact with the application UI by filling in the forms. Now the application is loading. It is loading data from the web. Once it is done, the script would take over once again, and it would change the value in this drop-down box. So accordingly, the application would change the detail that is available down here. You can see in a moment once, yeah. So the application, the automation script has changed this value, and the application now would change the details here. It has done so. Then we move on to the next page of the application, where we schedule a new evaluation. It is a form, and the test automation tool would has filled up all the necessary fields in this form. It is also clicked on the date picker, where it would pick the date from this picker, and then move on to the next screen, where a pop-up would appear, and the test automation would be done through extracting some text from that pop-up and comparing it with the expected value. So we're not just doing automation, but this is an end-to-end test automation where validation is also taking place through automated scripts. So this is the demo of the JavaScript framework that we have built. This framework, since it interacts with the source code of the application and it directly acts on the HTML UI, the same framework can be used for automating hybrid applications, whether they are published for Android or whether they are published for iOS applications, iOS smart devices. In the end, all I want to say is that a single tool or technology might not have enough magic to be able to do, to be able to handle all the varied challenges that smart device applications throw at test automation arena. But with smart combination of multiple available options, we are able to build solutions that can automate and overcome most of these smart device challenges. Intrinsic framework features like reporting, continuous integration, such features can be leveraged from our existing test automation frameworks, and our existing test automation solutions can be extended by integrating all these solutions available for doing automation of smart device applications as well. For native and hybrid applications, we still need the source code available to be able to do robust context-driven UI test automation. In case we do not have the source code available, in that case, we always have the option of doing image-based UI automation, which is an analog way of doing test automation. But such automation is expensive because it is entirely driven on the UI, and a number of factors like resolution, screen size hinder that display of the UI, as well as the UI keeps on changing, so it requires a lot of maintenance. Thus, over a longer period of the test automation project, this technique is not suitable. It's highly expensive. With this, I'm done, and we're open for questions. So over to Siddharth.
Thank you, Raman. I feel this was a very informative session, and I can see that our audience was very involved based on the number of questions received. So we'll start with the Q&A phase now and try to answer as many questions as possible. If any of your questions do not come up here due to paucity of time, please do not worry, as we'll try to answer them via email. So we'll start with the first question here. I think, Kunal, you can take this up. It's based on projections and costing. So is there a way to forecast project cost for automation testing to size the work to build the micro framework?
All right. Estimation and cost forecasting for building a micro framework includes the standard feature set of test cases authoring, using object repository creation, reporting, continuous integration, and then secondly, the test coverage based on user story complexity. So you can say that it is entirely not possible to do it without knowing the application and the user stories and the application architecture also involved in that. Thanks.
Thank you, Kunal. Let's go over to Ramandeep for the second question. Hybrid apps are the core of my business. Whether my apps are delivered via mobile devices or not, what percentage of QA costs can be saved in automation testing if I have the source code versus if I do not?
Okay, when we have the source code available, it is really easy for us to do context-driven UI automation, which everybody would agree is that it is a robust and stable way of doing test automation. Versus if we do not have the source code available, the option unless it's a web application. And since we are talking about hybrid applications, the way of doing test automation in that case would be to fall back to image-based UI automation. Now, since image-based UI automation, or rather any form of analog test automation, relies on screen position, there are a number of factors that comes into play, like the resolution of the screen and the size of the screen, and we already know that with over a longer development cycle, the UI of an application keeps on changing. So it's really difficult to maintain such kind of an automation over a longer period. It requires a lot of maintenance. Every time there's a small change in the UI, we have to create new scripts. In fact, if we want to run the same script on two different devices having different resolution and screen size, we'll have to create different scripts for those devices. Whereas when the source code is available, the JavaScript framework the micro framework that we talked about, this framework, since it does not rely on the image-based UI automation, does not rely on comparing images to identify the objects, this framework can be used for running the same scripts on different devices having different resolutions, and in fact on different platforms also, like iOS and Android. The same script, same test automation framework can be used for that. What I can say right now is, compared to if we have the source code and when we do not have the source code, the cost and the QA time is almost 2 to 3 folds compared to when we have the source code.
Okay, Brahman, I think we'll stick with you for the next couple of questions as well. So the next question is, it seems that you have developed ways to automate tests for a number of technical approaches to building mobile apps. Are you aware of there being some technical approach that you do not have an automation approach for as of yet?
Yeah, that is a very interesting question. Firstly, if we do not have access to the source code of the application, automating such applications is really difficult. We need to rely on image-based automation, and from my point of view, it is not stable, and I would not want to go to that route. So definitely this is very challenging. Secondly, there are a number of applications nowadays that use a lot of features like video and audio playback, games that use motion sensing. So right now we do not have good ways to be able to do automation and simulation of such user actions. So those kind of applications right now is still a huge challenge.
Okay, and the next one is, how good are the test management capabilities of these tools? Can you build a framework and test repository for this?
Yes, excellent question. That is one of the reasons that we heavily rely on open source tools, because they are highly extendable. In fact, in one of my demos, I've demonstrated how we have used our existing framework and extended it for doing automation of smart devices. These tools, the tools that we talk about, the smart device application test automation tools, as is, they do not have any test management capabilities. What we have to do is, in order to have these capabilities in our test automation solutions, we have to build frameworks on top of it. So you can build all the necessary test management reporting capabilities as part of your framework code. So that absolutely is doable.
Okay, and a very interesting question now, and I love the involvement here. Does image-based testing depend on comparing two images against each other pixel by pixel? How reliable is this method?
Yes, I was expecting this question. Definitely, image-based UI automation requires comparing images pixel by pixel. And yes, this method is not very reliable. But if you look at it this way, essentially there are two things for which we want to compare the images. First is to identify availability and position of an object, a smaller object, on the complete screen of the application. And secondly, for doing test validation, comparing the exact screen, making sure that all the layout and everything is on the screen and the text is available on the screen. Now for the first method, when we want to identify the object, we don't have to do 100% matching. Even if the matching has some tolerance, let's say 70% of the image is matched, That means the object is somewhat available on the screen somewhere, because we are just trying to identify the location of that object. So in that case, by changing the tolerance factor, we can make our scripts more stable, more reliable with this image comparison mechanism. But in case when we are doing test validation, we would definitely want to stick to 100% comparisons. So with these techniques, we can make this overall image-based UI automation a little more stable and reliable.
Okay. And for the next question, which is all of the discussion today has been around regression functional testing. Are there solutions or approaches for performance testing on the mobile devices? Now, Raman, let me give you a break on this, and I see Prashant very eager to answer this. Let me just introduce Prashant. So Prashant is working closely with Raman and has been spearheading many automation and performance initiatives here at Infotech. So Prashant, over to you for this.
Thank you, Siddharth. Performance testing on mobile application is especially challenging as it comprises of two components. One being the server-side response and the other being device profiling, that is the response of application on the device itself. Now we have devised our framework so that we can integrate both the components in that. Our framework is capable of integrating with performance testing tools like JMeters so that we can measure the server-side response, as well as we have introduced hooks in our framework which measure the device, the application response on the device itself.
Okay, and the next question is your overarching framework capable of running automation on multiple devices? Example for hybrid apps, you mentioned about the JavaScript micro framework. Can it run on both iOS and Android devices, Raman?
Yes. When we talk about hybrid applications, the JavaScript framework that we have developed, since it integrates with the source code of the application itself, the same scripts and the same framework can be used for doing test automation of Android-based hybrid applications as well as iOS-based hybrid applications. So yes, the framework in the current state supports all different kinds of smart device applications.
Thank you. The next question is automation critical to occur during and along with the development of the application? Kunal?
Yes, so that the regression time, can be cut down and more focus can be on the current feature set and the exploratory testing of that. Also, if we are doing automation along with development, we can have the automation test suite be integrated with the continuous integration server like Jenkins, and the dev team can benefit by knowing the impact of their change right away rather than after a couple of days by doing a manual testing and figuring out that you fixed one bug but you introduced a couple more in different areas. So it is critical, and it helps both QA and dev teams to deliver the software in an efficient manner.
Thanks, Kunal. Prashant, let's go over to you for this next question. Is Selenium WebDriver supporting Windows Phone?
Windows OS is a new entry into mobile arena, and it's been very promising. Work has been going on in developing the WebDriver solutions for Windows iPhones, which is still in progress and it's in infancy. Nevertheless, we can always use image-based testing to create automation scripts on Windows phones, which comes with its own lacunas, but is a promising solution for automation on Win phones.
Okay. And are the tests executed using emulators only, or it supports execution on real devices as well? Kunal?
The automation approach we take here at Infotech, we have ensured that the tests run on real mobile devices. It's difficult to have all of them in our labs. So for the ones which are new entrant into the market and we don't get our hands on, we do the testing using the emulators for them. Support of real devices is enabled for both web applications and native phone apps. So it is, it gives a real experience of how the application would be on the devices. So we do use emulator in cases we don't, have the real devices, but mostly we try to do them on the real device set by procuring them from the market or in collaboration, with the client. Thanks.
Okay. The next question, let's go over to Prashant for this. Is it possible to integrate the mobile web application automation with CI tools like Jenkins?
Absolutely. We have taken special care while designing the framework so that it relies on open source tools like Selenium and could be executed using build tools like Maven and Ant. This enables a close integration with CI tools such as Jenkins, TeamCity, etc. Not only the framework that we have designed can be integrated with common CI tools, it also supports remote testing. So you can have a machine connected to a network with one or more devices connected to it and execute tests on them remotely and in parallel.
Okay, I think we are almost out of time here. So let me just make a conclusionary note. So thanks again for joining us in today's web event and spending the last hour with us. I would also like to thank Kunal and Ramandeep for their presentation. We hope you find it useful and informative. As mentioned earlier, we'll respond to the unanswered questions via email. You'll soon receive a short survey about today's event. We would really appreciate if you could take out a few minutes to give us your valuable feedback. You may log off at this time. Have a nice day.